again, we want to try to sketch a derivative from these functions. Okay, so we have the derivative, the function, and we're going to try to sketch its derivative. So for example 3 here, 3a, this looks like a cubic function, so I should be thinking, I'm probably going to get a quadratic looking graph. I want to find the zero slopes here and here, and I want to locate my zero y coordinates here and here. That's important. I know it's positive through here, so I should be above the x-axis. Okay, through here. It's going to go up and back down. Okay, so it's going to go 0, steep, back to 0. And then I'm going to have negative parts here and here. Okay, so that means that I should have negative graphs going to 0, negative going to 0, and I have a quadratic looking function from that cubic function. Okay, so what about for b? Well, these are discrete slopes. These slopes are not changing. So what do these slopes look like? Well, this section here is a positive slope, and that slope is undefined on those endpoints because remember that we can't differentiate those corners like that. The next section here, we have a constant negative slope. So I'm going to be down here, and it's probably about equivalent, it looks like. So I'm going to be about the same distance down I was up to that point, and then that last point here, again, is discrete. I have to jump right away to a different slope. That point there is, it looks like the slope of the two green lines are the same, so I'm going to keep the heights of those slope graphs about the same. So the slope graph's going to look something like that. Okay. So for this one here, again, we want to try to find zero slopes. Okay, zero slope there. It's going to cross x-axis here. I've got negative slopes and I've got positive slopes. So here's my negative slope section. Okay, so it should be entirely below, but looks like I'm going to be near flat, and then it's going to come back to 0. Okay, so 0 gets a little bit more negative and then comes back up. Here I have positive slope, so it's kind of go from 0 slope to kind of more positive back to 0. So it's going to go 0 slope, more positive, and then it's going to come back to 0 slope. So my slope of that graph should look something like that. Sorry, the slope function should look something like that. Here I can maybe apply that idea that this is a 4th degree looking function, and I want to see if I can draw something that's probably going to look like a 3rd degree function. So I've got 3 horizontal tangents here, here, and here. So I'm going to start with those points. Okay, I'm going to start with my positive slope pieces here. So it looks like it's positive going to 0. I'm going to have negative in between here. So it's negative in there. So it's going to go down and back up to 0. Okay, it's going to be flat and then steep negative, flat. I'm going to have the same thing happening here, but it's going to go 0, steep, positive, flat. Okay, so I'm going to have probably a symmetrical looking piece there above the x-axis. And then lastly, I'm going to have this piece going negative, and it's going to look like that, but it's going the other way, and there's my slope function. And I end up with a 4th degree polynomial looking like a 3rd degree polynomial function. Okay, so this is, the main ideas again are these, right? We're looking for where the slopes are, where is it here? Where the slopes are horizontal or 0, where the slopes are positive, negative, the power rule relationship, and in addition to that, we can start looking for where are these slopes increasing or decreasing. Okay, that's a little bit harder to wrap your head around, but as we get more practice, we start seeing these a little bit better. But again, it takes practice. So I want you guys to make sure that you're doing those matching exercises and looking for those parts, sketching the graphs. Okay, use those apps that sketch the graphs for you so you can see how does a derivative trace out given the different parts of the function. Okay. Okay, so last thing is, what are some conditions that needed for a function to be differentiable? Well, what happened here when we had a corner? It is not differentiable. Okay, so differentiability is based on smoothness and also continuity. So we need smooth and continuous.